Okay, we're in Chapter 2, Section 2 of Barnett. Functions and Graphs is the chapter. Elementary Functions, Graphs, and Transformations is the section. And we have several objectives in the section. We're first going to look at the library of elementary functions, and let's see if you remember those. Okay, so we'll start with the most basic function, the identity function, denoted, well, just written f of x equals to x, right? That's the identity function. Whatever the input value is, that's the output value. So if the input is 2, the output is 2. If the input is 0, the output is 0. If the input is 5, the output is 5. You get the idea. The domain of this function, this should really say Blackboard R, should be denoted like this, all real numbers, right? Because you can have any input here, and it will produce an output. And as a result, the range is also all real numbers. You have all real numbers as possible outputs here. That's because all real numbers are the possible inputs as well. Okay, another function is the square function. H of x equals x squared. And you might remember that the graph of that is a parabola. This is the shape that we're referring to, the parabola that's drawn over here. For every input, such as 2, you square that input and you get an output, which is 4. And to square the input means to multiply it by itself twice, right? This is sort of like x times x. You could think of it that way. Once again, the domain is all real numbers, because any real number you can come up with, positive, negative, or 0, when you plug it into this formula, x squared, you are going to get an output. It's going to produce an output. There is no problematic values here. So this is negative infinity to infinity. All real numbers. However, notice the range is only the numbers that are bigger than or equal to 0, right? This is all the numbers bigger than or equal to 0. 0 to infinity. Why is that? Well, that's because any number multiplied by itself will either give you an output of 0 or a positive number. In other words, you cannot multiply a number by itself and get a negative output. That cannot happen. If you have a negative number, like negative 2, and you multiply it by itself, you're going to get a positive output, 4. That's why the range is only the numbers bigger than or equal to 0. How do we get 0? 0 squared is 0. The range cannot be negative. You cannot get a negative output with this function. Okay, another function we have here, m of x equals x cubed. You probably remember x cubed. Here's the shape of the graph as illustrated on this graph. And x cubed simply means take the input, multiply it by itself 3 times. Well, the domain is all real numbers, because once again, take your favorite real number, multiply it by itself 3 times, and you're going to produce an output. You're going to get an output. It's going to be a defined value. And as a result of that, also the range is all real numbers, because no matter what the input is, you're guaranteed an output. So that's the cube function. How about a square root function? We call it n of x here, right? And it doesn't matter what you call these, n, f, h. Hope you're keeping track and remembering function notation here. So this is square root of x. You might remember the shape looks as such. It's a smooth curve that starts at the origin and points to the right. The domain is all the numbers bigger than or equal to 0 again. In other words, all the numbers from 0 to infinity. The reason being is you cannot take the square root of a negative number and get a real number as the output, right? You run into a problem there. You need imaginary numbers when you take the square root of a negative value. Therefore, we restrict ourselves only to the numbers that are bigger or equal to 0 as our domain. And likewise, as a result, the range is also the numbers that are bigger than or equal to 0, right? Because you cannot take a number here. Here's an example, like 4. If I take 4 to be the input, then I will have square root of 4. And I know what some of you are thinking. Well, hey, square root of 4 is 2, but why is it that I can't say square root of 4 is negative 2? Isn't that also true? And here's the answer to that question. Well, square root of 4 is indeed 2. And when we talk about the square root as a square root function, we only take the positive outputs of the square root. Because look what happens if I consider 4, negative 2 as a possible output. Then I would have this point on my graph, right? And if I were to do it with all the other points, I would get this piece of the graph. And what's the problem with this? The problem is that it now fails the vertical line test. This is no longer a function. So when you take the square root of a real number, and we're talking about the root function here, the output is always going to be positive. That's why the range is 0 to infinity. Be careful with this, right? So I'm going to erase it here so there's no confusion. When you take the square root function of an input, the answer will always be positive. Okay? So that's why the range is 0. Okay, and then we have the cube root of x, which is x to the 1/3. Hopefully you remember this definition as well. The domain and range for this function is all real numbers, right? Because the input can be negative in this case. You just get a negative output as a result. Finally, the last of the functions is the absolute value function. You might remember the graph of this one looks like a V. Here it is. And the domain is all real numbers are, right? But you also might remember that when you have an absolute value, the output is always positive or 0. That's why the range is all the numbers bigger than or equal to 0. That's my range, bigger than or equal to 0. Looking at the graph, notice the V hits the origin, which is on the x-axis, but never ever goes below the x-axis, right? That's as low as it could go, unless there is some transformation applied, which we'll talk about transformations in the next video. So that's the absolute value function. You might also remember from your previous math course that absolute value is used to denote distance, and distance can never be negative, right? It can only be 0 or positive.